By the time I finish this sentence, 10,000 new stars will have exploded somewhere in the universe, as long as I pause like that. Most of them will have burned their last morsel of silicon gas and collapsed inward with nothing left to support their colossal weight. Others will have intertwined with a dance partner after millions upon millions of years of synchronous rotation, shaking the very fabric of our universe in one final, breathtaking flourish. Many stars end their lives in dramatic fashion, but they begin their lives much more quietly, in a nursery of dust and gas. As the gas clumps together, it heats, hotter and hotter until it begins to glow a deep red. The star is now a toddler, a mere dust bunny. When we were kids, we want nothing more than to grow up, but these toddlers take their time. They will continue to grow and pull material in from around them in these nurseries for at least 500,000 years. Some of these objects will actually stay here forever, never beginning their adult lives. Or maybe we can think of these as stars that are more effectively incorporating play into their daily lives. But for the largest, bravest stars, it's time for puberty. Just kidding. As it turns out, a star passes from a toddler to a stable adult instantaneously. Must be nice. Once a toddler has gotten hot enough to ignite, it reaches equilibrium and burns in this state for nearly its entire life. And that's not to say that stars aren't interesting. No, despite their overall stability, stars, also like some adults, can be exceedingly strange, especially during their midlife crisis. There are stars that pulse like a beating heart, and stars that spin so quickly that they bulge outward in the middle. There are even stars that burp out massive clouds of metal into interstellar space. This next simulation shows a star at the later stages of its life, dramatically boiling at its surface. Most massive stars bubble constantly like this, potentially attempting to regain the vigor of their youth. The same is currently happening on the surface of Betelgeuse right now, the red giant that's been dominating the news cycles recently. But a star's glory days must eventually come to an end. And as the sun sets on the life of one of these incandescent giants, a star offers us one final gift: its death. If a star is massive enough, it will power a brilliant explosion called a supernova. Supernovae enrich their surroundings with a truly astonishing amount of energy, enough to power 1 trillion Earth-like civilizations for 1 trillion years. Some of this energy is released as light, and as these photons take to the skies, they chart a path through the intergalactic darkness like ripples in a pond, carrying with them the indelible mark of their origins. Some, despite the seemingly infinite distances between us, end their journey at our pale blue dot, in the quaint outskirts of the Milky Way. Just this week, a few photons ended their journey of 500 million years at a detector in California. Here's their family portrait. We are getting better at catching the precious particles of light from these explosions by scanning more of the sky each night than ever before. In the year 185 AD, Chinese scholars marked the discovery of a new light in the night sky, a supernova. Today, we have discovered more than 20,000. And in 2 years, the Vera Rubin Observatory will revolutionize this search. Starting in 2023, from its perch atop a tall Chilean mountain, this observatory will take pictures of the entire southern sky every 3 nights for 10 years. The observatory was named after the pioneering astronomer Vera Rubin. Her work provided the first convincing evidence for dark matter, and it was universally rejected when she first presented it at astronomy conferences worldwide. Despite never winning the Nobel Prize, with this observatory, her legacy stands tall. And she also has an asteroid named after her, but the Vera Rubin Observatory will discover more supernovae in its first year than humankind has ever witnessed before. By carefully reading each of these tombstones, we enhance our understanding of how these stars lived out their lives and what awaits us at the very end of it all. The incredible brightness of supernovae allow us to measure distances to nearby galaxies, which can tell us how fast our universe is expanding. This is a critical number for understanding the nature of dark energy. Current measurements give 2 different answers, and they're both pretty sure. So we'll rely on each new explosion to tell us whether we must overthrow our current models and return to the drawing board. Some particularly resilient stars may live on as ghosts after their death. Shedding worn-out shells, they can collapse into some of the densest objects in the universe. Within my lifetime, we have gone from guessing whether these objects really exist at all to learning just how photogenic they really are. The explosions of stars also produce the dust and gas that will later give birth to new stars. These new stars carry the DNA of their ancestors with them, and they'll pass it on, too, when they die. The universe, as it turns out, runs an incredibly efficient recycling program. We might learn a thing or two by looking to their example. A small fraction of the dust from these explosions does not become new stars. Tiny particles forged in the bellies of a massive sun coalesce and form larger particles. These particles are to become planets, and eventually, us. We are the leftovers. For this reason, the winds from cosmic explosions carry the seeds for countless new worlds and new forms of life. We continue to find new planets every day, and each one has a star's death to thank for its genesis. Though it might not feel like it, our lives on Earth are intimately linked to the lives of the gaseous giants above us. The oxygen in your blood and the calcium in your bones are the relics of faraway stars. The branches of our family tree span trillions of miles and billions of years, and its roots include every species on Earth. We do not yet know if life exists on other planets and other galaxies, but if it does, then it too will share the building blocks from this, the largest cycle of life there is. Thank you.